just like what we did with the sine function and graphing its most basic, we're going to do the same thing with cosine. So I want to graph y equals cosine of theta now. And if we remember, cosine of theta from section 6 was the same thing as our x values. Actually, I'm going to make this f of x. Okay, we're talking about cosine. So as we look at our unit circle, whenever I'm pulling a degree measure, I'm now looking at the x values to come up with my cosine function. So cosine of 0 degrees would be the same location as my x value of 1. Cosine of 45, coming up here, looking at the x value, that's the same thing as this first square root of 2 over 2, which we said before was 0.71-ish. Cosine of 90, coming up, it's the x value, it's 0. And then you can start to apply the same things over and over. We have our x value over here for 135 as negative square root of 2 over 2, which is negative 0.71. Cosine of 180, that's going to be negative 1. 225 is going to then be negative square root of 2 over 2, which is negative 0.71. 270, we are at 0. It's the x value, 315. The x value is square root of 2 over 2, which is 0.71. And then finally, 360, we're back at the height of 1 again. So graphing this time, what it would look like at cosine of 0, we had a height of 1. At cosine of 45, we were at 0.71 or square root of 2 over 2. Cosine of 90, we were at 0. 135, we were at negative 0.71. 180 was negative 1. 225 was 0.71. 270, we were back at the height of 0. 315, 0.71. And 360, back at 1 again. We can draw in our graph again as best as possible. And it will look like that. Again, I'm sorry. It's not really supposed to look like a V down at the bottom. It's supposed to look more like a nice curve. That's the general idea as to what your trig function for cosine would look like. Again, that would be considered one period of, or one cycle of cosine.